All right, so this is obviously coming from our AP unit. This is 1-3, which is called rates of change in linear and quadratic functions. So we're continuing with our rates of change conversation, everything that we talked about in 1-2 with rate of change continues, but now we're narrowing it down to linear and quadratic functions. So a refresher on, again, rate of change. The rate of change is the change in output over the change in input. It's the change in the dependent variable over the change in independent variables. For specifically linear functions, it is your slope, or y2 minus y1 over x2 minus x1. So if they give you coordinate points, you can literally use that formula to find it. If they give you a graph, you could count it, okay? If they gave you an equation in slope-intercept form, then you're looking at the m. The average rate of change is constant for every linear function. So if I had a table of values or I had a graph and I counted my change in y over my change in x, no matter what 2 points I picked, I would always get that, okay? The actual rate of change is never going to change for a linear function. Then we're going to do something like finding the rate of change of the average rate of change. So when you find your rate of change, let's say we find our slope, okay, and that slope is the same for the entire linear function. If I wanted to know the rate of change of that rate of change and I subtracted them, it would give me 0. There'd be no change. So if the slope is 2 over 3, it's going to be 2 over 3 for any pairing of point, right? So if I wanted to find the rate of change of the rate of change, I would do 2 over 3 minus 2 over 3, 0. 2 over 3 minus 2 over 3, 0. It wouldn't matter where you picked, okay? Your rate of change is 0. The rate of change of the rate of change is 0 for a linear function, okay? So we're going to do that a lot. We're going to start talking about how, because it's one of the ways, if you're given data, you can determine if something is linear or quadratic or cubic or if it's raised to the 4th power, quadratic. Like you would do the rate of change of the average rate of change. So we're going to do it a lot. We start with the lines. So again, these hopefully these should be easy. It says find the average rate of change for the linear function, not the rate of change of the average rate of change, just the average rate of change. So we're looking for what here? Slope. So if I look at A, how do I find slope? It's 3 over 2. It's whatever's attached to that x, right? It's your m. That's your rate of change or average rate of change. How about B? What's true about this line? It's horizontal, and horizontal has what kind of slope? 0. Okay, so your rate of change is 0. If we wanted to, if we had a different line, I could literally count my rise over run. So if it wasn't horizontal, I could just count the change. Example 2 says the table gives values of the function f for selected values of x. If the function f is linear, what's the value of f of 12? So first of all, we have a table of values, which in a linear function actually duplicates as points. And if we want to find f of 12, we have to figure out what that linear model is. So we have to figure out what the slope of this line is, and then use the slope and either B or one of these points to make an equation and then find f of 12. So it doesn't matter which pair you pick. If I pick these 2 points, I can do -3 minus 0 over 0 minus a -2. That becomes +2, and I get -3 over 2. Same thing would have happened if I picked these 2 or if I picked these 2. Because it's linear, they shall be the same. So that's my m, or my rate of change. And then in the equation y equals mx plus b, the b is your y-intercept. If you look at the points that are given this time, the y-intercept is when x is 0. So it actually gives you that value. And so I can say y equals -3 halves x minus 3 is the equation of this linear function. If, for example, they didn't give you the y-intercept this time, then you can take any of these points and use them as your x1, y1 in your slope or point slope equation, or I can use them in my y equals mx plus b by plugging in for x, y, and m and solving for b. So there's a couple different ways to have gotten the equation, but once you get it, you need to find f of 12. So negative 3 halves times 12 minus 3. 2 goes into 12 3 times, or sorry, 2 goes into 12 6 times, and you'd get negative 18 minus 3, which is negative 21. And negative 21 is your value of f of 12. All right, now we're talking rate of change of a quadratic function. What do we notice about this? Did it change? Is there any difference between rate of change of quadratic and rate of change of linear? Nope, it's exactly the same, okay? The difference is that when you're doing rate of change in a quadratic function, whether it's pointing up or it's pointing down, if I want to find the rate of change of 2 points, let's say I want to find the rate of change of this point and this point, you're actually finding the slope of the secant line of that. So the secant line is, remember, secant goes through a circle, it hits it twice, right? So that's the idea behind it. Instead of finding the slope by counting across the curve, because you can't count that, you're actually counting the slope of the secant line. That's what it's called, okay? That's what calc calls it. Your book very rarely, or your content really very rarely refers to it as the slope of the secant line, but that's what it is, okay? So you would just do the same thing we did before, y2 minus y1 over x2 minus x1. So it says find the average rate of change for the quadratic function on the given intervals. Here's my function, okay? And then you want to find it for each of these intervals. We won't have to do this again because we're going to learn a pattern, but let's plug it in. So if my interval is 1 to 2, then I'm going to find f of 2, subtract from it f of 1, and then put it over 1 minus 2. So I'm just finding the rate of change like we did last section. So f of 2 would be 2 squared minus 2 times 2, or 4 minus 4, which is 0. F of 1 would be 1 squared minus 2 times 1 over, or not over, sorry, I'm just going to, not yet. 1 minus 2, which is negative 1. Over 2 minus 1.
So for this, they're going back to using the interval notation?
Yeah, well, yes. I actually think you could see it both ways. You could see it like this, too. Yeah. I'm pretty sure on the AP homework it does it in interval notation.
Why?
I don't know. Just wait till we get to the end of the chapter. It goes back to interval notation for, we're going to do like increasing, decreasing, and that kind of behavior. I mean, end behavior, it goes back to interval notation. Yep. Don't ask me why. My job is just to teach it to you. Okay. All right. So now I got 1 minus a negative 1. That becomes positive 1 over 2 minus 1, which is 1. So the rate of change from 1 to 2 is literally just 1. Now I go to B. B is from 2 to 3. So I'm going to find f of 3 minus f of 2 over 3 minus 2. F of 3 would be x squared, or 3 squared minus 2 times 3. 9 minus 6, which is 3. Now we already know f of 2. We did it over here, so we don't have to do it again. That's 0. Over 3 minus 2, and I get 3 over 1, which is 3. Is it a problem that those are different? When does rate of change have to be constant?
Linear.
Only when it's linear. This is not linear, this is quadratic, okay? So it makes sense that it shouldn't be the same. Doesn't mean it can't, but it makes sense that it shouldn't be the same. All right, now I go f of 4 minus f of 3 over 4 minus 3. F of 4 is 4 squared minus 2 times 4, 16 minus 8, which is 8. 8 minus f of 3 comes from B, that's 3 over 4 minus 3, and I get 5 over 1, which is 5. Still good? Now I'm doing f of 5 minus f of 4 over 5 minus 4. F of 5 is 5 squared minus 2 times 5, 25, minus 10, 15. 15 minus f of 4 was 8 over 5 minus 4, and I get 7. What do we think E is going to be? Probably 9. Let's see. F of 6 minus f of 5 over 5 minus 6. F of 6 is 6 squared minus 2 times 6, 36 minus 12, 24. Minus 5, f of 5, which was 15. Oh, this should be 6 minus 5. I rewrote it. Over 1. And my answer is 9. Yeah.
Will it always be in like a pattern?
Yep. So what do you notice about the average rates of change?
Increase by 2.
They increase by 2, okay? The rate of change of the average rates of change of quadratics is constant. So in this case, if I took any pairing, again, has to be on the same interval. 3 minus 1, that's 2. 5 minus 3, that's 2. 6 minus 5, that's 2. 9 minus 7, that's 2. So the average rates of change are all, they are constant. Well, no, the average rates of change are increasing by 2. But there is a pattern.
Is there always gonna be a pattern?
Yep. It might be increasing, it might be decreasing, but it should be by a constant rate, which is what this says. The rate of change in quadratic functions, the actual rate of change does not stay the same like it did for linear, but the rate of change of the average rates of change is constant. Just wait till we do rates of change of the rates of change of the average rates of change, because it's coming. Why? I mean, why? It's actually, once you understand the process, it's actually quite an easy way to determine if something is squared or cubic. You're just subtracting numbers. Yeah.
How deep does this like go?
I mean, it could go on forever.
So you
How
can
much?
make
How many?
The rate of change of like the rate of change. Of
So, like, if something is raised to x to the 4th, then the rate of change of the rate of change of the rate of change of the average rates of change
So it's
is constant.
on the exponent. For how many
It determines the
rates of
exponent.
change
Correct.
it
So the degree of the polynomial can be found by taking your table, finding the difference, finding the difference of the difference, finding the difference of the difference,
So you
finding the
get to
difference of the
0.
difference, until you get to something that is constant. Yep. You could go one more level and it'd be 0, but you're really just finding where it's constant, where it's all the same. All right. Find the rate of change of the average rates of change. So if I asked you to find the rate of change and it was, let's say it was linear. If I asked you for the rate of change of linear, you would give me the slope. What if I asked you for the average or the rates of change of the average rates of change of a linear function? What's the answer? 0 all the time, okay? Does that make sense? If it said y equals 2x plus 3, that's linear. The rate of change of this is 2. But the rate of change of the rates of change is 0 because it's always 2. So you're always going up by 2. So then you would find, so that the initial rate of change is 2, but then it's 2, 2, 2, 2, 2. So the rate of change of that is 0 because it's never going to change. Okay? 2, correct. So average rate of change 2, rate of change of the average rate of change 0. For linear, okay? For quadratic, we have to find it. So we're going to just pick some points, okay? To be consistent with like a PDF, they will pick -1, 0, 1, 2, like something like that, okay? So we're going to do the same thing. We're going to find f of -1. We're going to find f of 0. We're going to find f of 1, and we're going to find f of 2. Sometimes you will not spot it without the extra points, so we're going to find them all. So -2 times -1 squared plus 10. -2 times 1 plus 10 is 8. f of 0, negative 2 times 0 squared plus 10, 0 plus 10, which is 10. Negative 2, 1 squared plus 10, negative 2 plus 10, which is 8 again. Negative 2, 2 squared plus 10, negative 2 times 4 plus 10, negative 8 plus 10, which is 2. Now this says the rates of change of the average rates of change. So the first change I find is the rate of change. These are my values, right? Then if I did the difference between these, it's going up by 2. The difference between these, it's going down by 2. The difference between these, it's going down by 6. It is not constant yet, which makes sense because it's not linear. Now I want to find the rate of change of those average rates of change. So I go deeper. I do negative 2 minus positive 2, and I get negative 4. And I do negative 6 minus a negative 2, and I get negative 4. This is my rate of change of the average rate of change. I found the values first, so I took and plugged in f of negative 1, 0, 1, 2, and that's these values. So these are just my function values. That has nothing to do, that is not yet a rate of change. Then I found the difference between them. Because I went on an interval of 1, I'm literally just subtracting. So 10 minus 8, 8 minus 10, 2 minus 8, and that's these values. That's the average rate of change. So the first time we found it, it's the average rate of change. If it was linear, they should be the same. So it makes sense that they're not because this is quadratic. Now I want to find the rate of change of those. And so I did negative 2 minus 2. And I did negative 6 minus a negative 2. And both of them gave you negative 4. If it's quadratic, they should be the same. Ding.
If you were, wouldn't negative 2 minus positive 2 be 4? Just go 4?
No, it's negative 2 minus, so negative 2 minus 2, negative 4.
How would you know, like, which?
Because you go y2 minus y1. If I switch the order, then this would have also been switched. I would have done 2 minus a negative 2 over negative 1 minus 0.
So the left one is always going to be the one that you're changing the sign of.
Sure, yes. If you're doing right minus left, yes.
It's always right from left.
You don't have to go right from left if you're just picking two general points. But if you're using those points, this point was technically negative 1, 8, and this point was 0, 10. So if I do y2 minus y1, it would go over x2 minus x1. That's a change of positive 1. So I don't have to do over x2 minus x1 if I go right minus left. And I'm going up in increments of 1.
Will there be times where there's no answer, or does it always have to?
They always have an answer. Yeah. We went up in increments by 1, right? Like we made it easy on ourselves by going up in increments by 1. And if we do that, then we do right over left, right over left, right over left. If you don't go up by increments of 1, you have to do change in y over change in x. You have to account for change in x. All right, you try it. And notice we haven't used our calculators yet. This would not be on a portion in which you'd have it. All right, did we get the f of right? Yes, f of negative 1 is 5, f of 0 is 0, f of 1 is 1, and f of 2 is 8. That's my value, right? So if I want my average rate of change, I'm doing 0 minus 5, that's negative 5. 1 minus 0, that's 1. 8 minus 1, that's 7. Again, the only reason I don't have to account for the change in x is because I went up by 1. Now that's my average rate of change. I want to find the rate of change of the average rate of change. So I want to do these. 1 minus a negative 5, that becomes 6. 7 minus 1, that is 6. So the rate of change of the average rate of change is 6. Dane.
Could you also just do what you change in the left to get to the right?
Like make that negative and switch it?
So kind of like.
You're saying change it and then add it, change it and then add it? Yeah, it's the same thing. Yeah, because subtracting is the same thing as changing and adding. Same thing, yeah. All right, so now we go back to concavity, okay? What was true about concavity? Obviously, from our graphs, we looked for our U's and our N's, or smiles and frowns, okay? Now it's saying find the rate of change using a table. And if I want from there to see the concavity, I have to compare them. If the rate of change is increasing, then it is concave up. And if the rate of change is decreasing, then it's concave down. So we're not talking about our rate of change of average rate of change. We're talking about just the first level, okay? The average rate of change. So we'll get a table. It will look something like this. It's going to say the values of the function are given at selected x values in the table below. The function is either concave up or concave down, but not both. That would be confusing. Then it would have to give you a range. It would have to say from this interval to this interval. Okay, this one's straight across the board. Determine if the function's concave up or concave down. So first, note my x values. They're going up by what? 1. So I can actually just find the change in my y's. If they weren't going up by 1s, I would have to, in order to find the rate of change, put it over the change in x. Okay? But because they're going up by 1s, I literally can just do 22 minus 20. That's 2. 22 minus 22 is 0. 20 minus 22 is negative 2. 16 minus 20 is negative 4. What's happening to these values? They are decreasing, which means this is concave down. Down for decreasing. Yep.
For like one where it says that either concave up or concave down, you only have to find the first two, right?
Sure. Yeah. Uh-huh.
Can you like show if it wasn't going up by one? Like if it was going up?
Yeah, so I would say, like, let's say this was 17. I would do 22 minus 20 over 17 minus 15. So it'd be 2 over 2, which is 1, like that. If it was reversed, though, like let's say this was 13, now I'd get 22 minus 20 over 13 minus 15, and I end up with a negative. So that would, I'd have to see you'd have to see at least 2. Is that what you mean?
Yeah.
Yeah.
'Cause you only
Yeah.
need two,
Yeah.
'cause they're the same.
Sure. Correct. It's because it says it's all increasing. I mean, all concave up or all concave down. Yep. So just pay attention to those x values. If those x values go up by 1s, you don't have to take in account them when you do your other values. But obviously, if they do change, you got to make sure you account for it. Questions? All right. Clear that on homework for this evening, you are doing the 1.3 PDF and AP Classroom questions. Okay, the leniency's out the window when it comes to AP Classroom questions. We are getting warmer. We're getting our feet wet. You have to do them. And you have to show work for the ones that require work. So I want to see the score from AP Classroom and I see the work from AP Classroom. If you have no idea, you get to a question, you're like, oh my gosh, I don't know. You better make an attempt and then put a question mark. I don't care. That's fine. You can do that every once in a while, okay? But as we go through this week's like is not that difficult, to be honest. I feel like, I'm not saying you're going to get them all right the first time. It's okay. You don't have to be perfect, okay? But I am saying that they are less confusing, in my opinion. So I better see the work from the PDF, which is if you're plugging in points, you're not using your calculator, you're plugging in points because you're not going to have your calculator in those kinds of questions, okay? And then you want to make sure that you're doing the AP Classroom questions and getting the score. Is that clear? Because now I'm going to start docking. Like if those things are missing, my kind request to add them is gone. You're getting points docked.
So we need to add the score. The score is
Like the results where it shows you what's right and what's wrong. Yeah, and realize that for some people it took a little bit of time for that to register, right? So doing this homework at 7:55 is not going to work tomorrow morning. What I mean. Okay. Yeah. God bless you.